Okay, cross country was gone yesterday. We're gonna get everybody back on board hopefully today, and we're gonna do number 6 together on your homework assignment. I had you bleep out everything except for the first 5 numbers, just because I don't want you to have to do standard deviation without that, like with that many numbers. And same thing with number 7. Just do standard deviation for the first 5, okay? So we're going to do range. We'll talk about variance. We'll answer that question here in a bit, and we'll do standard deviation. So if I'm looking at range for just the first 5, how do you find range, by the way?
Most minus the least.
Range. So it would be, I don't know, 252. Is that the biggest?
254.
Yeah, the 254 minus 189. So the range for those guys is going to be like 65. There you go. Range is 65. Okay, we did range, check. Now we're going to do standard deviation, and then I'll tell you what variance does, okay? Standard deviation, we're going to do them the longhand way. We did 2 different formulas yesterday. Which one did you like better? The second one. Okay, let's do the second one. So here's the formula for the second one. It is the square root of n times the sum of all the x squareds minus the sum of all the x's squared over n times n minus 1. Is that true? Is that the right one? Okay. That's the formula. Okay. So we're going to do those 5 numbers, and we're going to figure out what these are. When you do this table, if you still want to do them in table format, he's a very much smaller table. What are my x's? What goes in this column?
189.
Those numbers. 189, 254, 235, 225, and 190. Okay? Then what goes in the x squared column? Those numbers squared. They're going to be kind of huge. Okay, somebody have them.
35,721.
35,721. Okay.
64,516.
516. Okay.
55,22,5.
Okay.
50,62,5.
50625.
Yes.
Okay.
36,100.
Okay. There you go. Those are my x squareds. All right. So if I'm going to the formula, what is n, by the way? Like, what do I plop in for n? 5. There's 5 numbers, right? So 5 goes here. Boop. I'm going to write him like this. Square root 5 goes in for n. All right. Now this guy, this is the sum of all the x squared. So which column am I summing?
The right one.
The right one. The sum of all the x squareds. That's this all right here. Okay, Delaney, what you got?
242,187.
Okay. 242, 187. That's the sum of all the x squareds. 242, 187. Okay, minus. This guy here is a little bit different. The square is on the outside, so I'm taking the sum of all the x's, and then I'm squaring that number, right? What's the sum of all these guys right here?
1093.
1093. Okay, so I'm taking that 1093 number, boop, 1093 number, and I'm going to square that. Yeah? A little bit different. Sum of x squareds versus sum of x's, that number squared. All right, on the bottom here, I have 5 n's, and then n minus 1 is going to be 4. Okay, here's what I want you to do. Take your calculator out. I want you to calculate this. Everybody plug that in. Practice plugging that in. Everybody. Delaney's done a lot of the work for us. You do this part.
I'm finally halfway smart in math for once. After last year.
Woo woo!
I was making up for it.
You can do it. Stats is not bad. I like stats.
Way better than
814.3.
What?
814.3.
Is that before or after you take the square root?
After.
After 814.3?
No, that's before.
After, I think.
Okay.
It's 28.
I got 28.536, yeah.
28.536?
Yeah, that's what I got.
Beautiful. That's the standard deviation. Okay?
So why did we only do the first 3?
What do you mean?
Of
did
all
the
the numbers
first
we
5.
did, or only first 5?
Because the more you have, like, the longer this gets and the more cumbersome it is. So I was just trying to make it easier on you. Because doing a manual standard deviation is very disgusting if you have, like, more than 5 numbers. It gets to be a long process, and I just wanted to cut it down for you. Okay, now, we did the range. The range was 65. The standard deviation was this guy. They ask for a number which is called the variance, okay? And I don't really like variance a whole lot, but they ask for it, okay? The variance is this number before you take the square root, okay? So in other words, the variance is equal to what?
814.
Is equal to the standard deviation squared. Or the square root of the variance is equal to the standard deviation. Does that make sense? Yeah, yeah.
5 and 4.
The 5 and the 4. Where are you at?
There's 5 numbers
The
and then.
n.
Oh, yeah. Yep. N times n minus 1. N, there's 5 numbers, because we just did the first 5. So then n minus 1 would be 4. Good question. Yep. Yeah. So,
Look at that.
when they ask for the range, the variance, and the standard deviation, you know how to find all 3 now. The variance is just the number that you get before you take the square root. That's what variance is. Okay? And they use that for comparing things as well. Not as much as standard deviation. Standard deviation is the number that we use the most often to compare. But sometimes they use variance. Okay? So the variance is the square of the standard deviation, or the square root of the variance is equal to the standard deviation. Make sense? Clear as mud? Something? Yeah? Okay? How about that? Good? All right, so 7, you're going to do that same way with those first 5 numbers. Yeah? Good? Okay, but let's go and let's talk the rest of part A, and then we'll stop at part B. Okay? So, or part 2, right? Part 2 we'll save for tomorrow. But we'll do the rest of this part right here. And this one's not too bad, okay? You ready? There's like 2-ish main concepts in what we're going to learn today. Ready? They have something called the range rule of thumb, okay? And there's 2 main concepts for the range rule of thumb. Number 1 is estimating the range. Okay? Or estimating standard deviation, not range. Estimating standard deviation. That's one thing for the range rule of thumb. When they talk about the range rule of thumb, they'll say one of them is estimating the standard deviation, okay? That was a huge, long process that we did for each one of those, okay? There's something really short, really fast, really easy that I can do to get an estimate of what the standard deviation is. And it is this, very easy. I take the range and I divide by 4, and that's going to give me an approximate amount of what the standard deviation is, okay? That's the very quick, easy way to estimate standard deviation. Now, why don't we do that all the time? Why don't we just do range divided by 4 all the time for standard deviation?
Won't be exact.
Because it won't be exact. And the range does not take into consideration every single number, true? That's why this is only a guesstimate, okay? Versus like the standard deviation takes in every single number into consideration, right? Okay, so if I want a rough estimate of the standard deviation, I'm going to take the range and divide by 4. So they're going to have us do that on example 4. They say my highest number is 77.8 and my lowest number is 16.02. Okay, so to find the range, I'm going to subtract those, and then I'm going to divide that number by 4. And that's going to give me approximately what the standard deviation is. Somebody subtract those and divide by 4. 15.445. That's what they got for a standard deviation. Now, the standard deviation that I got when I did it both ways, right, was 16.4549. Is this pretty close to that, though?
Yeah.
It's giving me a rough estimate, right? Like a very fast, rough estimate, okay? So when they say use the range rule of thumb to find the standard deviation, they're saying just take the range, divide by 4, and that's going to give you a rough guesstimation of the standard deviation without having to do the really, really, really long process. Got it? That's number 1. Then there's a range rule of thumb for estimating what like high and low points are. So I'm going to say highs versus lows, okay? All right, here's how this works. You use the range rule of thumb to figure out what is considered or what is deemed to be a high value versus a low value. And here's how this works. Think about this as a number line, and you have your average here. So I'm going to put X bar. I'm going to put the average here in the middle. Okay? If you add the standard deviation once and add the standard deviation twice, this is a cutoff mark for what's deemed a high value. Anything beyond that is considered to be a high value, right? So you can pick out what your outliers are based on, is it 2 standard deviations above the average, right? Same thing goes for below average. If I subtract the standard deviation once and subtract the standard deviation twice, this is where the cutoff mark is for low values. Anything that is beyond that is considered a low value, right? So if you have an outlier that is beyond that, that's considered a low value. Got it? So let's look at example 5. Use the range rule of thumb to estimate standard deviation of the sample of 50 data speeds. Those 50 data values have a minimum of this and a maximum of this. What did we have? Oh, shoot. I switched these around. Whatever. They give me all the information up here. I switched these two problems around. Whatever. We need the standard deviation is 16.02 and the mean is 17.60. Whatever. I switched the information from the two problems around. Okay. So these are the two pieces of information that we need to do it this way. Okay. I'm going to put this on a number line. So the two pieces of information I need are the X bar, which is the average. I'm going to put that here in the middle, 17.60. And then I'm using that standard deviation to figure out what is considered low and what's considered high. All right. So to figure out the high number, I start with that 17.60 and I add the standard deviation twice. So I add 16.02 and then I add it again, 16.02. And that's going to be my cut score for any high values. What's considered a high value? If I add that thing twice,
39.64.
it'd be like adding 32.04. So what did you say, 49.64? Yep, 49.64 is considered a high value. Anything beyond 49.64, okay? Now, on the low end, if I subtract 16.02 twice, minus 16.02, that would be like subtracting 32.04 from this 17 number, right? My number's going to be negative, like negative, I don't know, 15 point, I don't remember. Somebody do that. What's 17.60 minus 32.04?
Negative 15.56, something like that.
What'd you get?
I got negative 14.44.
14.44? That's probably right. So that is a low value. Now, question. We're talking like data speeds. Can you have a data speed that is negative? No. So really, my low end is actually 0. Does that make sense? Okay, because I can't go beyond into the negatives, right? Because you won't have any values that are lower than 0. So you could put negative 14.44, that's fine. But just realize that if we're trying to figure things out, like what's considered a low value, there won't be any low values, right? Because nothing will be lower than 0. True? Okay, so they ask the question up here, determine whether the data speed of 77.8 is considered significantly high. Is 77.8 considered a high value? Is it an outlier? Yes, because it's beyond that 2 unit mark, right? 77.8 is over here in what's considered significantly high. So yes, 77.8 is significantly high for a value. Yeah? So, two things. To find the standard deviation real quick, you take the range and you divide by 4. Done. To figure out what's considered low and high values, you take the average and you add the standard deviation twice and you subtract the standard deviation twice to figure out your cut marks.
Can you go, what was the,
Yeah. I did the problems in the wrong order. This stuff should have been up there in example 4. That stuff should have been down there in example 5. Whatever. It's all the same. Okay? Good? All right, and then variance down here, it says variance is equal to the standard deviation squared. The square of the standard deviation. It's basically what you get before you take the square root. Right? It's that number you get. That's what the variance is what you get before you take the square root. Or variance equals the standard deviation squared. Right? The square of the standard deviation or standard deviation is the variance square, the square root of the variance. Make sense? Okay? Good? Yeah? All right, so now you should be able to do like number 1. This is the RAIN rule of thumb for estimating what is low and what is high, okay? So you're going to do that number line. You're going to put your X bar, your average here. You're going to subtract it, add it twice, subtract it twice, right? On number 1 to figure out what's low and high. And then they're going to ask you, is this number a low number? Okay? Number 2, same thing. What's low, what's high? Number 3, if this is your standard deviation, what is your variance? Okay? Number 4, don't worry about number 4 yet. We'll talk about number 4 tomorrow. Okay, so 1, 2, 3, and then you should be able to do 33, 36, and 41. So tomorrow, for tomorrow, save 22 and save number 4. Do everything but 22 and 4.
Number 1, do we have to find the exact standard deviation like it says, or?
Number 1, they give you a standard deviation. Oh, no, wrong. Number 1, you're not adding. You're doing the find the range divided by 4 on number 1. Sorry, I lied. You're taking the range dividing by 4, and then they say, this is what the exact is. Is it close? Right? So range divided by 4 on this one is the strategy that you're going to do. Number 2 is when you're finding your low and your high. Okay? Questions? So, everything but 4 and 33, or whatever that was. 4 and 22. Good, good? Actually, and not 41. Everything but 4, 22, and 41. Yeah. Yeah. Okay? Good, good? All right, there you go.